Hello, I'm here with a project on how we can approximate the amount of oxygen in the atmosphere using the things available in our own home. So the materials I have for this project are thali, a mug of water, a glass, sign pen, a scale, diyo, a burning candle, and finally 2 thick books. So let's begin. First of all, let me calibrate this glass with a sign pen and a scale. So now I'm done with calibration, as you can see, and the least count of this calibration is 0.5 cm. So now after I am done up with calibration, let me take the thali and I'm going to pour some water in it. Okay, so now let me keep a diyo and let me burn it. So the diyo is lighted. Now I'm going to place a glass over this. So I'm pretty sure you all know what's going to happen after that. Of course, the diyo is going to be extinguished. So why that? Because burning requires oxygen, and after some time we have placed the glass, whole oxygen inside the glass is going to be consumed, and then there will be no oxygen to support burning. At this moment, we would be able to see water climbing up the glass. So again, why that? It's because the place of consumed oxygen is going to be occupied by water, and that water that climbed up the glass will lead us to the percentage of oxygen in the whole atmosphere. Seems exciting, yeah? So I'm going to put the glass over this and you will see the water will climb up the glass. So 3, 2, 1. So you can see the fire has been extinguished, and you can also see the water running up the glass to cover up the place of oxygen. So the volume of water that has entered the glass is the volume of the oxygen that was there inside the glass initially. So by calculating the volume of water, we can calculate the volume of oxygen that was in the glass, and total volume of air in the glass can also be easily calculated by just some maths. And then, as you might have known, where there is science, there is assumption. We are also going to assume that the gases inside the glass represent the whole set of gases in the Earth's atmosphere. In this way, we can calculate the percentage of oxygen in the atmosphere. Here, the level up to which the water has climbed is 0.5, 1, 1.5, 2, and it's 2.25. So I will note it down. The height of which water has climbed is 2.25 centimeter, and the total height of the glass is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it's likely to be 10.8 something. So it's 10.8 cm. And now we are going to calculate the diameter of the narrower end and broader end. So for this we need 2 books, which are here. So we have these 2 books, and I'm going to put this cup in between them and let the books touch the glass, and then remove the glass and get the diameter of the wider and broader ends. And so first let me put the glass in between the books. Okay, and now after that I will remove the glass and measure the distance between the books. So it's around 7.7 cm, and I'm going to note it. 7.7 cm. And now to measure the narrower end. Okay, so I've used the books. Okay, now remove the glass, measure it. So it's 5.5 cm. So let me note it. 5.5 cm. So I've noted them all, and now we have finished our practical part and we only have some maths remaining. And now we are in math section. So I have here a formula to find the volume of a glass, and it is if Q is the radius of big circle and R the radius of a small circle and h the height, then the volume of glass is 1 by 3 pi r q cube minus r cube by q minus r. I have derived it in the PowerPoint attached with it. And so finding the volume of glass, we will use the same formula, and from the experiment we have radius of big circle to be 3.85 and radius of a small circle to be 2.75, and then height of glass is 10.8. So using the formula from previous slide, we get the volume of glass to be 1 by 3 pi r q cube minus r cube by q minus r, and when we substitute the values, we get the volume to be 372.91 cm cube. So this is the volume of glass. And for the volume of water, we again have the diameter of large circle to be 7.7 and radius to be 3.85 and radius of a small circle to be 2.75 and height to be 10.8, and the height of water is 2.25 cm. And now we are going to find diameter of upper surface of water, and we will use unitary method here. So with the increase in height by 10.8 cm, we can see the diameter has changed by 2.2 cm, and with the increase in height by 1 cm, the diameter would change by 2.2 divided by 10.8 cm, and with the increase in height by 2.25 cm, diameter would change by 2.2 by 10.8 into 2.25 cm. So that is 0.4583 cm. So from here we can say that diameter of surface of water, which is 2.25 cm of the base, to be 5.5 plus 0.583, which is 5.9583 cm. So from there we can get the radius of the surface of water to be 2.97915 cm, and when we substitute that in the formula to get the volume of water, which is in glass shape, the volume of water will be 1 by 3 pi r q cube minus r cube by q minus r, and when we place the values there, we get the volume of water to be 58.034242 cm cube. So now to find the percentage of oxygen in atmosphere, from the experiment we have that volume of water that is climbed up the glass is equal to the volume of oxygen that was there in the class previously, and so the volume of oxygen is equal to the volume of water in glass, which is 58.034242 cm cube, and the volume of air is equal to the volume of glass, which is 372.91, and then percentage of oxygen is equal to volume of oxygen or volume of air into 100%. So when we put the values, we get it to be 15.562533%. Now we had assumed that the gases inside the glass represents the whole set of gases in the atmosphere, though my glass could have been affected by previous two attempts before the actual attempt, so I could not get the correct answer, which is to be 20.95%. So according to my project, the percent of oxygen gas in atmosphere is 15.562533%. So that's the end of my project, and I'm very grateful to Chan for the opportunity.